It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 245. If f is continuous on this closed interval and differentiable on this open interval, which of the following statement is not true? Okay, answer choice A. F prime is equal to 0 for some x in this interval. Well, that's not always true, right? It's because if a function always increases or always decreases, then we don't have a tangent line that has a slope is equal to 0. Okay, let's look at this function. Here, let's say we have f of x. Looks like here's -4, here's a 0. So let's say it starts from here, it goes to here. Let's say we have this function, and this is f of x. You know, if we look at the slope, this is the slope of tangent line, right? If we look at the slope, if f function is always increasing, strictly increasing, the slope is always positive, right? There's no x value such that f prime is equal to 0 in this interval, right? So this is not always true. So the answer must be A. F prime is equal to 0 for some x only if f of -4 is equal to f of 0. This is Rolle's theorem, right? Okay, here, let's say when x is -4, the value is right here. When x is 0, the y value is the same as f of -4. Then, let's say we have this type of graph, increasing, decreasing, like that. Then we do have tangent line that has a slope is equal to 0, right? That x is going to be between -4 and 0, right? This is only true when the endpoints, the function values of at endpoints are equal to each other. Okay? Answer choice B. F prime is equal to f of 0 minus f of -4 over 4. This is actually average rate of change of f on this interval, right? Here, y2 minus y1 over, this is x2 minus x1, right? If we rewrite this expression, this denominator, x2 minus x1, which is equal to 4. So that's average rate, the slope of second line. That is equal to f prime, the instantaneous rate, right? Slope of tangent line. Well, this is true by mean value theorem. So B is true by mean value theorem, right? The conditions for mean value theorem, remember, it has to be continuous on closed interval and differentiable on open interval, right? So since f is continuous and differentiable on this interval, this is true by mean value theorem, all right? Okay, answer choice C. Okay, it says f has absolute minimum on this closed interval. This says f has an absolute maximum on this interval. Well, this is about extreme value theorem, right? If function is continuous on closed interval, f has an absolute minimum and absolute maximum on this closed interval, right? That's extreme value theorem. That's true, right? Okay, if we look at this function right here, this function with the black color, let's say f of x is this. Here we have absolute minimum. Here we have absolute maximum, right? If the function is this blue color, if this is f, we have absolute maximum here, we have absolute minimum here, right? So if the function is continuous on the closed interval, it has absolute minimum and absolute maximum by extreme value theorem. So these two are true. So the answer must be A.